Good morning, good evening, good afternoon, and good night. Time dilation can change someone's sense of perception and sense of time depending where they are on Earth. My name is Flora Carnero, and today I'll be discussing the psychology behind the human mind in regards to space exploration. The College Board provided stimulus states by Johann Norberg in False Nostalgia that nostalgia is a natural, even important state of mind. According to the psychologist, anchoring an identity in something enduring helps us when all that is solid seems to be melting into the air. Everything changes, but we need a sense of stability and predictability when things change too fast. We lose our sense of control. This is probably why a yearning from the past is especially likely when we experience rapid transitions. This relates directly to my research question, as nostalgia can be used as a safe way and an escape from unforgiving environments in long-duration space missions. My question is, how do the effects of general relativity, time dilation, negatively affect the psychological questions when faced with the abandonment of Earth for space exploration? It is important to keep in mind the psychological effects of time change and this dilation on humans. So, since I have a position-based argument, there's no direct answer, but through my research, I was able to come to the conclusion that space explorers suffer emotional, psychological, and philosophical issues when presented with long-duration missions conjoined to the theory of time dilation. In this picture, it shows a video when Cooper comes back from the space mission. He goes to Miller's planet, and every hour on that planet is 7 years on Earth. They experience a challenge, and when they come back, it's been 3 hours and a few minutes. But back on Earth, it's been 23 years, 7 months, and 8 days. On the right side of this image, there's the black hole also utilized in the movie Interstellar. NASA credits it for its accuracy and realism. General relativity. General relativity, so how do I explain this? In this image, you can see the small object and its small curvature. Compared to the space-time curvature, the larger object will create a bigger indent. So in the gravitational and in gravity, in the space-time continuum, the smaller object and the smaller curvature has a lessened effect on the space-time continuum. But general relativity is Einstein's theory of gravity, describing how massive objects like stars and planets warp the fabric of space and time, causing what we perceive as gravitational attraction. Instead of viewing gravity as a force, it explains it as the result of curved space-time influencing the motion of objects. The image shown depicts this exact concept, where the small objects could cause a small curvature due to its lower gravitational pull and weaker effect on the space-time continuum in comparison to the larger object and its effects. To simplify, time works as a fourth dimension in the space-time continuum. The theory of flat spacetime follows the Friedman-Lemaitre-Robertson-Walker metric, which explains the continuous expansion of space, stemming from the Big Bang, that describes a homogeneous expanding universe that is path-connected but not simply connected. This allows for the wormhole theory to seep in. The wormhole theory goes along the space-time continuum as it bases itself on the concept of warping the space-time continuum to manufacture a shortcut between two distant points in the universe. Taking into account that time is a possible fourth dimension, the FLRW metric establishes the idea that a wormhole will be found at any and every cosmic dimension at any period of cosmic time in the cosmological model. The space-time theory, in connection with Einstein's relativity theory, combines the three dimensions of space with the dimension of time, intertwining them into one single form and establishing the four-dimension continuum, signifying that when and where an event occurs cannot be separated. I'll be discussing the emotional, cognitive, and philosophical aspects of my research question. For the emotional, I decided to focus on the Mars 500 mission, which was a psychosocial isolation experiment conducted between 2007 and 2011 by the European Space Agency in preparation for an unspecified future crew and its adventure to Mars. Results from the Mars 500 experiment showed subjects experienced depression and mental decline after a long period of isolation. While this experiment covers more than exclusively astronauts, The isolation experienced by these groups can be detrimental to the cognitive abilities needed to survive and perform certain tasks that are deemed crucial for high-risk survival situations, such as prolonged space exploration, which would consequently reduce the efficiency in performing high-level decision-making and multitasking during space missions. This image is also taken from the European Space Agency from the Mars 500 experiment. This image illustrates the cognitive effects of long-term spaceflight, emphasizing stressors like microgravity, noise isolation, and circadian rhythm disruption, which can lead to depression and cognitive decline. Time dilation, though not visually depicted, adds the psychological burden by distorting astronauts' perception of time, compounding disorientation and emotional strain. This aligns with concerns in the article The Burden of Space Exploration on the Mental Health of Astronauts by Alessandro Aron, where prolonged space exploration or prolonged separation from Earth and routine leads to spatial temporal isolation. As astronauts are increasingly removed from natural sensory inputs such as sunlight and organic landscapes, the resultant sensory deprivation and emotional nostalgia may foster a psychological crisis marked by heightened loneliness, neurocognitive decline, and existential angst, ultimately endangering both individual mental health and collective mission viability. This image is taken from the Translational Psychiatric Volume 13, article number 342. To finish it off, the philosophical side of things. The graph illustrates the complex relationship between population growth, resource consumption, per capita food availability, pollution levels, and industrial output over time, highlighting concerns about Earth's sustainability. This visual representation aligns with the debate on space exploration role in ensuring humanity's survival, echoing discussions on the Kuznets curve, which suggests that economic development initially increases, then decreases inequality as the country develops. Additionally, time dilation effects experienced by astronauts due to high orbital speeds, as predicted by Einstein's theory of relativity, can lead to slight differences in aging compared to individuals on Earth, further complicating perceptions of time and existence during long-duration missions. In this context, some assert that to truly uphold the value of human life, it is not only immoral to endorse birth control, but also imperative to advocate for maximum reproduction. This viewpoint posits that opposing birth control and promoting high birth rates are essential to ensure the long-term survival of the human race, viewing procreation as a moral imperative to prevent extinction. So the whole ethics proposal of this is that to continue expansion, because we're meant to leave Earth, we're not meant to stay there. So we need to have maximum reproduction, and they're against the use of birth control. Thank you.
All right, 2 questions for you. How did your research question evolve as you worked through this whole process?
Well, I knew I wanted to make it about space since the beginning, and then when we got the resources from College Board, I was able to associate it not only to the science of it, but the psychological effect it can create on astronauts due to their long journey and isolation from home.
And if you had more time, what additional research would you do? Good question.
I think I would, not if I had more time, but if I had more information, because if it was a few years from now, I'd be able to use new found evidence to support my claims even more, because all this is theoretical, so it's not concrete evidence that I can make it a law. It's just theories that I can base upon my question.